Awesome. So we are live, guys. Wonderful to have you guys again. As you guys continue to join our webcast series, I just wanted to give you a bit of sort of a background on what we have done so far. In the last couple of webinars, we spoke about, obviously, this, as you guys know, this is all about energy and AI. So how AI and the energy sector at the intersection of these two domains, how do we create innovation? So the last couple of webinar sessions were more into, giving you a bit of a perspective of how traditional energy companies like oil and gas are using AI. And now this is a very fascinating topic to me as well, and also to Tanishta, because here we are actually going into a domain that we love as much, if not more, which is alternative energy. So, think in terms of solar panels, so wind energy, electrification is a huge sort of, trend. Giant batteries are coming up, various models are coming. Decarbonization, which is obviously a focus for not only the traditional energy sectors like oil and gas companies, it is also, call it a sort of a, there is for them a ground zero. They start with, well, supposedly with a zero carbon sort of foundation, one would like to believe. In any case, I think that's the topic which is going to be in this webinar. And Tanisha is going to take over, and I'll sort of continue to kind of help you guys, support you guys with your questions that you may have. And looking forward to getting you guys also involved in this wonderful discussion where we talk about a couple of things which Tanisha will explain. So get started, guys, and let's see.
Uh,
Have you guys
Hi,
participating?
hi everyone. So we are back again. Yeah, today's topic is definitely something I'm also very interested in, renewable energy. Earlier, we were all talking about oil and gas. Basically, we were trying to make use of a well-to-well correlation use case and go through the basic of from starting from the basics of a model development, and then we also showed some results how to do your data set development. However, in this topic, we will actually give everything in a concise form. That being said, is you have a data set, and this is also a combination of another technology that's drone. So how drone is sending the data, how you combining the drone data and importing it into the model, and then making inferences, and how it's actually bringing value to your business case. So everything will be covered in this topic. So I hope you like this as much as we do about solar panels. So so all the codes to this. By codes, I mean we will show a demo at the end of it. So the demo codes are also in the diff of a EarthScan webinar GitHub. We can provide the link as we go on into the discussion. But we've been showing this for a while, and I think people also know who is following our webinar. So let me start the presentation now. So the way we'll try to organize this presentation is the part what is solar as a renewable energy. We'll talk about definitely solar. Everyone knows about solar. We'll go and give an overview of PV cells, infrared imaging from drones and all. And then we'll talk about a new technology, drone. We are not, of course, expert in this technology, but the data that we are using is from the drone technology. So from drone, and how it is kind of making things efficient for a solar farm, and then how you take this drone data and make a good use of it, so you can actually make your maintenance or a prediction much more faster in a solar PV farm using deep learning models. And then we'll give you a hands-on demo. We'll show you a demo basically. I think we can provide a link also where you can also try it out. But right now we are just showing it through our laptop, like a local host. Yeah. So let me start the presentation as So, solar as a renewable energy, there's much everyone knows about it, right? So, what's new about this? So, or why is it very important? It's because you have um, unlimited supply of solar energy, right? And definitely making good use of it is what solar renewable energy is all about. The good point is there is no emission involved, and so no CO2 problems over here, no CO2 capturing, nothing needs to be involved here. The only thing you need to have are good PV panels that will be installed rightly, maintained rightly to give you a right amount of energy. And then there is another positive side of solar energy is once this energy is produced, like for a day, you can produce this energy and you can also store it, right? You can store it in a battery and you can just use it for later purpose, right? So another thing I feel important is you can have it in any scale, right? Starting from installing it at your own house to any big farms, right, who are providing energy in a large scale. And I do think the installation is pretty simple rather than well going into conventional energy like oil and gas, which needs a lot of setup. This is quite simpler in comparison to that. So, having said that, the world is still not there, right? They're still not producing that much of solar energy. Um, there are few problems associated with it. However, in this discussion, we'll talk about mostly how do you maintain this, because there's a lot of times you have problems with weather, problems with all these PV panels. There's quite a bit of anomaly happening, and that's kind of depleting the desired output that you want. So, having said that, as you can see, there's quite a good use of solar energy happening in North America and then also in Asia, Europe. Not so much in Africa. There's also in Australia. So that's being said. It's just the dark reds are where you have the maximum reliability in the solar on the reliability on solar energy. Okay, so maybe just the facts, how different companies like the giants are kind of moving into or investing a lot on solar. So, for example, Walmart, it has installed around 200,000 solar panels in their store and in their distribution center across USA, which is kind of generating more than 85 million kilowatt of energy each year. So it's powering 8,000 homes. Also not enough, but you can do better, right? Where it's a good step how they are going about. Google has also taken its part. They have installed 2.5 million solar panels, as also Apple and big giants like that, right? I know Amazon did invest also a lot, but I don't have the numbers right now. So now coming to a use case of this, or maybe just think of a solar farm. So how are the KPIs that we need to measure, right? So that we get the right amount of or a good performance, a good output from all these panels. So one of there's few ways this energy is lost from. So from a theoretical value, you can lose your energy in various ways. One is weather, and the other one is mostly like anomalies. So the parameter that is there's a performance ratio, that is a ratio between production and theoretical production of a plant. So, so of course, when the plants are looking to increase their performance ratio every time, right? And then there is a capacity factor. So the maximum capacity the plant can produce versus the capacity it is producing at this time, right? So also this can happen between because of few factors, weather anomaly, right? Inverter efficiencies. Inverter is, so you might know that this PV panels, we'll also talk a little bit about the PV panels. So these PV panels generate DC and then it is converted into AC through inverters. There's also a lot of different varieties of inverters out there who are converting DC to AC. Probably it's also a factor on the efficiency of the inverter, that you can get this output, right? And finally, there is a power factor. Like it's if it's one, of course, you have all the powers that is generated from the farm reaching to different places or homes. And of course, if it is going below, then there is a loss in transmission, and this is quite common in any kind of like when you have a power transmission happening. So now, what we wanted to show you a use case of maintaining the solar panels, because a farm, as you can see, it has millions of these solar panels, right? And then maintaining these panels, or yeah, predictive maintenance of these panels become a very big hassle. And if you go with the use case of manually looking into this, it's quite impossible, right? So there's we are presenting a comparison table, which actually shows that if you are doing this manual inspection of a particular farm, I kind of forgot what is the number of PV panels this farm has for site one. However, you can see that if you go into a manual inspection, it's like taking you like 800 hours to do an inspection of the entire farm. And then when you actually install a drone, then it can do this inspection for you in 24 hours. And similarly, these are for other three sites where the similar situation is happening. Like drone can actually replace this maintenance for the farm and take and increase the efficiency largely to like more than 90% in most of the cases. So having said that, there are definitely some usefulness of using drone, because you can there's different types of drones, payload and things like that are also over there. But you can have cameras installed on a drone, which is actually taking this PV infrared images, which is being then analyzed by the by a machine learning model, right? And it's easy to use, easy to maneuver, and things like that are some of the what do you say, the advantage of using a drone in a maintenance purpose. Okay. So so now we'll just quickly tell you what is a infrared solar module, or maybe what images are these drones taking, and how and what is our AI model actually seeing on from these images, right? So it has an infrared camera which can show what temperature you have. So, for example, on that roof, you have snow. Probably the white colors are snow, right? Then, when you have an infrared camera running through it, it can show you that that's a cold area. And over there, you have direct sunlight, and it seems it's a very sunny day. So you have really like a dark red kind of temperature for those panels over there. And something is little bit off for the panel at the right, at the left. There is kind of a orangish tinge over there. Could be something happening with an anomaly problem, and that's the reason it's not at that temperature which it has to be, right? So these are the ways you can actually find out some kind of anomalies from these kind of images. And that's what we were focused into, developing a model to look at these anomalies and capture these anomalies, because these anomalies in course of time reduce our efficiencies. Okay. So okay, we have a drone question over here. Not really machine learning, but let's see. What is the name of the process that allows a drone to fly autonomously along a predefined route? So the options are path planning, object detection, simultaneous location and mapping, reinforcement learning. I mean, it's quite simple. It's just in the it's in the question.
Maybe 1 or 2 seconds. There are still 25 people, which is great. I mean, it's a Friday. I know it's a weekend, close to weekend. So I would say, you know, I'll take a wild guess. I'm not a roboticist, but okay, someone is giving some answers. Okay, hey Ramnath, slam.
C.
That's what they
Hmm.
are saying.
Okay. Then probably it's C. We thought it was A. Path planning.
Yes,
A.
I think that's
Okay.
the correct answer. So, I mean,
Yeah.
it is a path planning algorithm, but SLAM is also not so far off actually.
Mm-hmm. Yeah.
Although SLAM is used more in in autonomous vehicles, but several algorithms are also focusing on. Oh, great! There's lots of answers. I think you guys are trying to win a competition. But I think
So,
SLAM is also not an incorrect
mm-hmm.
answer, but it's for another autonomous vehicle where in driverless cars. But
Okay.
good try, guys. Perfect. Okay, Soumya is saying B. I,
Uh,
I don't know why it shows all. I know
yeah.
that
It's A. Yeah. I'm not sure
yeah.
why.
I have no idea. It always changes colors here.
Hmm. It's a
Anyways,
Anyway, so as I was mentioning, I'm trying to get the use case again out there. So it's a combination of two technologies. You have solar PV panels, so the and then you have the drones, which are actually taking these images to an infrared camera, where you can see the temperature difference, and then you are using your machine learning, artificial and AI applications to understand how much is the anomaly present for each of these panels, because each of these panels together will actually define your efficiency of a solar farm, right? So what happens is, once the drone has given this extracted images, we have trained a model which can actually tell you what is the percentage of anomaly each of these cells can have. So bear in mind, it might be a combination of anomalies. It might not be just only cracking or hotspot or things like that. So I can also show you some of the common defects that you can have in a solar PV panel. So you see the first one is cracking. So you can definitely have a crack from anywhere, maybe a hailstorm or anything like that, like dropping on those panels. Because I think I'm not very sure about those panels, but those are silicon particles, right? Quite sensitive, I would say. So if you initiate a crack, and then as any cracks goes on, it just goes quickly. And if you have a, and it also has the temperature dependencies. So if you have a sunny day, maybe the crack goes a lot. Maybe on a cold day, it might not. But what happens ultimately, it kind of reduces your efficiency, right? So it's quite important that you do a forecasting. If you have a crack on a particular day like this, and maybe you don't know, but in just a week's time, it will just go offline because the crack has gone so far, right? Then there is a hotspot. So in a hotspot, it can happen in various different ways. Hotspots are basically you have a localized heating. So maybe there is any kind of obstruction on the cell, or some local problems within the PV cell in a material way also. Then you have a temperature, like a high temperature, and in course of time this can actually also start growing and affecting the other like the entire area of the PV cell, and this also hinders your efficiency a lot. Then there are micro cracks. If you, it's more in terms of a cracking mechanism also, but micro cracks can also grow, and then um, grow and make a bigger cracking problem. And then there is diodes. So this one is, I believe, is more from the modular part. So all these cells are like connected together. connected together, maybe two or three cells are connected together, and if there is a diode problem, yeah, some kind of problem in the module of these cells, then three of the cells, I'm not sure on this one, but I'm reading from, read somewhere, so that's what I'm trying to explain over here. So three of the cells can go completely offline, and this can actually make your um, efficiency go 80% low. And sometimes this kind of diode problem can cause a short circuit or an open circuit issue also. And that in turn would actually go and hinder your inverter. So that so this kind of problem is quite major if it's not taken care in the initial stage. So yeah, this is an important problem. And the later problems are shadowing, vegetation, things like that. So you see there's a lot of vegetation growing over here. And this is actually covering a lot of the part of this solar PV panel, which also definitely is a problem with the efficiency, right? Um, but like you cannot predict in time how much vegetation can grow. However, all the other problems can be definitely forecasted before it goes to a really bad state. Okay. Terry, you want to talk about maybe how deep learning is helping, or how we can use these architectures, all these kind of.
Yeah, sure. So, very high level, guys, because I think you guys already know that today perhaps you may not be even using convolution neural networks. You might say there are better, improved models of image and object detection, like DETR, or VIT kind of models, vision-based, transformer-based models. But so DenseNet essentially is it's basically what it stands for is densely connected convolution neural networks, DenseNet. It was introduced in 2016. It basically composes of a few blocks. So there is a dense block, as you can see here. There is a transition layer, then you have growth rate. So basically what growth rate means is it's a hyperparameter that actually controls the number of features maps actually you have which are produced by each convolution layer. All right. And then you have bottleneck layers. And then finally you have a global average pooling. So, I mean, there is a paper from 2016. You can search for DenseNet on arXiv. You will find that paper if you want to learn more about DenseNet. The most important thing of DenseNet, besides being densely connected, as you know, in convolution neural network, you're essentially trying to reduce, the number of units, your neurons. Essentially, you keep reducing the units, keep doing max pooling, and eventually you arrive to a result. That has worked reasonably well. But in DenseNet, you do a few optimization techniques like global average pooling. There are different kind of pooling techniques: max pooling, average pooling, stochastic pooling as well. And essentially, the goal is to arrive to better performance with fewer features. So essentially, same like CNNs. And what it actually allows you is you have less of a problem of vanishing gradients. So essentially, the flow of the gradient flow is improved with very few parameters as compared to CNN. So that's the only difference. But sure enough, I mean, as you know, if you're using Keras or any other tool, you're calling either you call it DenseNet or MobileNet. There are so many of these models that were coming. AlexNet was the one that was the predecessor. So essentially, DenseNet. I've used that also in many other applications, even in healthcare, trying to identify um, um, benign or identifying cancer cells from benign cells. So DenseNet have proven to be also be quite useful in many applications. So in this case, I think the DenseNet 121 architecture, like ResNet, also has many variants, right? So this 121 architecture was used in this application. If you have any questions, please ask me. But again, like I said, DenseNet is almost what 7, 8 years old. I'm not saying it's invalidated. People use it in many traditional applications, or a good old fashioned machine learning or good old fashioned AI, if you may call that. But it's pretty useful in applications today as well.
Okay. So once we use this DenseNet one-to-one to create a model, we save the checkpoints, and then what we did was then we created APIs from those model checkpoints. Okay, and we used Fast API. Not going into more details of Fast API, maybe for another time. However, if you kind of query a Fast API endpoints, you can actually see there we did two endpoints. And if you upload a model, sorry, not a model, an image file to it, which is kind of a PV file. So this data set was actually taken from, I think it was raster map. So this company actually have taken a lot of these drone images. So they have used this drone on different solar farms, and they have compiled a very useful data set where you can train the models on different anomalies to detect different anomalies of these PV panels. So this is an example where you can have no anomaly. So this PV cell is showing no anomaly. And over here, you can also already see some change in like some change in the coloration, right? And this is an example of a diode problem. Um, so there are about, I believe, 11 anomalies that they have provided. Most of them were more catered towards cracking, hotspot, and diodes. There were few on the other anomalies, but also in our model we could actually train more on this issues that I discussed, like those 5 issues that we have discussed earlier. So anyway, when you upload an image into on this API endpoint, and then you just in the post call, and then you and it gives you a, what do you say, a percentage of anomalies. I think it's a little bit smaller on in font, but this gives you percentage. So it shows you all the anomalies that can be present in that cell. Mostly there is a high number that is what you can actually consider that is the major anomaly or the defect in this cell. There could be a presence of other anomalies also. So with that, okay,
Maybe you
do
can
you
answer
want
this
to?
question.
Yeah,
Yeah.
let's. Oh, any specific reason why we prefer? Was there an edge over the accuracy comparison? I think we just used DenseNet, and we are now trying to also improve the model in some way. I believe, yeah, I believe it was just because it had other applications in other areas, like of course those healthcare and all, and those were quite useful. But if you go into other papers also using this kind of data, they have gone into simple models and even like other transformer based kind of models. But we just use DenseNet to begin with, and see how it was performing, and the performance is quite good. Okay, so let's, yeah, this is a question. Yeah, what is the process of adjusting the parameter of a machine learning algorithm to optimize its performance on a specific task? I believe the answer over the options given here are a little bit off. One, there should be another option. I'm just giving the answer. It's a hyperparameter tuning. So when you are training a model, it's going to tune your parameters, right? So there are various
So,
parameters.
but the question is, what is the process of adjusting the parameters of a machine learning algorithm to optimize its performance on a specific task? Come on, guys, 2 minutes. I know it's weekend. We all want to go home. I understand all that, but if you have been sick and tired of listening about ChatGPT and the madness that is going on the planet, it's time to go back and reading the books and the fundamentals, because in the end, everyone is using this shit. So, all right, I'm going to say I'm going to type my answers here. Maybe I'll sort of try to divert the attention. I'm going to lie. Okay, so that's at least. Uh, so Hemanath is saying validation. I took a shot at this. Hirsch is also saying validation. I don't know what the answer is. I think the answer should be A, but
The answer is A. Yeah.
a lot of guys are biting the bullet. It's weekend, we know, but yes, A is the answer. Perfect, guys. Move on. Yes, perfect.
Okay. Cool. So again, that's problem. Anyway, now it's time, show time. So we'll show a demo how everything comes together. For this, let me start presenting my screen. Just give me a minute. Okay.
All right, live demo. So do you want
Yeah.
to explain the flowchart, or was it enough
I
for?
will just explain as we
Yeah, yeah,
do
yeah.
this,
That's
keep
fine.
doing
That's
this.
fine.
Okay. So this is a Streamlit application. It's visible, right, Terry, on the screen?
If you play it, I
Yeah.
can see a black screen. Yeah, now I can see a
No,
screen
okay.
running. Yeah,
Okay.
perfect.
So yeah. So here you can actually so if you can provide your own location. So right now we just played with Delhi, India over here. So suppose it's not, this picture is not from Delhi, but anyway, this shows you how a solar farm looks, and these are all these small lines over here are basically those PV panels. So you can do two ways. You can actually upload an image. You can have a PV image, a drone PV image. You can upload it over here. So it goes and uploads it. Upload an image. Okay. So it did upload an image. So we combined few of these images together and try to check. So what we were trying to do is try to regenerate a solar panel. Like it's a combination of few of these PV cells. So if you are combining all these cells together, and then you are trying to see, like, if your drone is moving past this, and this is kind of a green screen, or maybe the green zone of interest that your drone is seeing, then what does it see? And so it basically sees all the anomalies over here, of course. So the most important anomaly that is happening over here in this particular cell mostly is soiling. However, you can also see some percentage of multi-cell. This probably is the one that is related to the diet problem. Then there is also a little bit of cracking. Shadowing is also over there. And then there is a vegetation growth. But however, I would just stick to most of these, the top three or four kind of problems. The rest is probably not there. It's just quite minute. So anyway, so if you are trying to see what is over there, and you can do this regularly, like just think of it happening in real time, and you do it in today, and you can do it tomorrow, and you can see which one is growing, is soiling there, or is the multi-cell problem going higher than this. So this is kind of an usefulness of this kind of applications. Um, So, and you can also create just a pie chart of showing what is the percentage of all this anomalies happening over here. Okay, and then you can also have your some preload images. You can, having said that, you can have images anywhere, and you can try out with that. We have provided this code if anyone is interested in Earth scan. I'll just, after this presentation, I'll put the link to that code. And you can also try it out yourself. Okay. Let me stop sharing this and we'll go to the presentation. Okay. Um, Actually, I would basically show you the location again. Uh, just go to the defect GitHub. Okay. So, if you haven't gone to our previous webinars, so these are all the, you can have links to this webinar, or this is the YouTube link to the webinar, the previous webinars. So we had 3 webinars earlier. We have also provided the codes over here. So you can see the notebooks here, and just trying to show you. Then there's a link to all the raw data that are here. Um, After this webinar, I will update the code, but I believe it should be somewhere in the notebook. If you go to notebook, you can have the Streamlit application over there, the code for the Streamlit application. But we are also providing presentations linked to the notebooks, so you can also try out yourself. Okay. Yeah, that's mostly it. Let me stop sharing. And then I think with that, we end this webinar. Oh, we have another trivia question. So, which algorithm is commonly used for image recognition tasks in deep learning? Hmm. Okay, you can use to. Can you a bit? Can you elaborate how you are mapping this anomalies to information vector? Okay. What do you mean by information vector? Is it the percentage you mean?
I'm not sure. Maybe Soumya, can you elaborate a little bit? It's a good question, but perhaps. Uh, well, okay, everybody got the answer right. Perfect. I'll go
Yeah,
back
yeah.
to Soumya's question. So, mapping anomalies to the information vector. Maybe you can describe a little bit the question, Soumya, so we can understand what you mean.
Yeah, I can actually also share the raster image dataset link. People can go through this raster map, raptor map, raptor maps, raptor maps, PV solar. Okay.
You can always ask questions later, Soumya. And send us can always comment later once the webinar is over, so we can answer your questions. All right. What
Yeah.
did you want to talk
Okay.
about, Tanisha? Raster map? What were you
No,
saying?
yeah, we can just show the raptor maps, right? The solar,
Yeah,
the
yeah.
dataset link. Yeah. So I'm sharing over here. Okay.
How do you map image data?
We map the image data. Uh, okay. So yeah, we trained the model, right? So if you look at a raptor, if you look at the data set, so it has a anomaly, right? As I showed you in the beginning. So what we have in the data set is something like this, right? So you can have different PV cells of this. These are our ground truth, right? So these are labeled. So this one's no anomaly, the other one's diode, right? And you have all those other 11 anomalies there. Now, since our model is trained and it knows that which one is which anomaly, So that's how it's giving an answer to what it's thinking, right? That what kind of anomaly it is, and it's giving it's not giving one answer to it because it could be a combination of few. So that's the reason you that's how we know what anomalies are there. So we are kind of picking the highest percentage from these anomalies. So as I showed in an example in the live demo, right, that there was a soiling issue with one of the cells, right? So uh, we picked it because it has had the highest anomaly, so soiling anomaly. And then, I mean, that's how we are kind of mapping. If you are talking about that, that's what we are picking, actually.
All right. You can check the dataset paper which these guys had released. I think this was 3 years ago. Not sure if they have refreshed or added
I
more.
think they're adding, they're still adding, they have added new data to it. So
Okay, maybe I do look at it. It's very interesting because this is a startup in US, and I believe there are a bunch of classes. They seem to have indeed improved upon that. That paper is here. And take a look at it, Soumya. If your question is not answered, we can kind of get back to you also on this. Good question, by the way. But like I said, we didn't collect the data set ourselves. It's a data set we've used. Yes, that's obviously that's true, of
yeah,
course. Yeah.
yeah, yeah. Yeah, that's how it's defined, right? The labels are defined to a JSON file. Okay. So I think with that,
Cool.
it's the end of our presentation. And do you have any more questions? Um,
Any other specific questions? So let me just give you a bit of a rundown. So a couple of things I didn't mention. We are trying to stay low key, and we are on a path this year to raise a significant amount of funding. As you all guys know, that alternative energy, solar is just the beginning because you're collecting energy, but you have to eventually convert that energy, store that energy, transport that energy through transmission sort of boxes, through the similar process which oil and gas industry does, and then you are passing it through the grid, microgrid constructs, and then eventually going to the super grids. But now everything is changing because energy is being harnessed not just from solar. It's going to be harnessed from wind. There's going to be a bunch of electrolysis process going on to convert it into other new forms of energy to transport, like hydrogen, etc. So I think there's a lot of exciting things that are going to be coming as we start building our tools towards providing our technology platform that is able to assess not only the anomalies, which is more predictive maintenance kind of a service, but also trying to give a more holistic view on the asset utilization and risk management. And these are the two things which every manufacturer, operator, and even the suppliers of these services are interested in. So over the next few months, you will see us sharing some interesting information with you guys. For example, wind turbine, electrification, electric battery. Those are very interesting topics as well. We are working on these at the back end. So that's the startup. It's called GreenScan. We are revamping a lot of structure. So there's going to be a new website in the next couple of weeks where you will get a really holistic understanding with our software and our dashboards that will be coming over time. So I hope it gives you guys a bit of an idea. Thanks very much for listening. 45 minutes is a long time these days when people are trying to understand what is the technologies being used. Uh, Please keep building AI because that's how we all succeed together. When you build AI, meaning when you build your own models, when you're understanding how to sort of harness, clean, scrub, and eventually use those data sets, that's when you have a full control of the stack. And I was just, it was interesting. Paul Graham, who's the co-founder of Y Combinator, he had shared a really long list of startups. There are like 1,250 startups with $1 billion or more valuation. And I really liked Elon Musk's comment, which Elon Musk made just a couple of days ago, 2 days ago. He said that it's a pity that 90% of these startups will fail because they're all running and building SaaS models and consumer driven services. And no one is investing his time and energy in heavy industries and manufacturing and all energy sectors, etc. No one is going out and building these new technologies, hardware and software solutions that actually matter most. And we believe in the same vision as well. It's about really doing all the hard things to solve hard problems, because those are the companies I believe will sustain. Hopefully we also would like to be in that group. And so that's why we don't go into fashion shows talking about valuations. For us, it is to work with energy companies, to work with operators, to work with the grid operators, and try to come with answers that these people will be struggling with. There's a lot of energy congestion going on. Even in the Netherlands, in the next year or so, there's going to be sort of problems of shunting and also rationing of energy because they just cannot cope up with all that energy. The capacity is already at the maximum. So in a strange way, we are harnessing a lot of energy. We cannot store it. If we can store it, we cannot transport it. If we do transport it, we don't know what price should we be transporting it. If we do understand the price, we don't know what price should we sort of negotiate with the homeowners and other small operators, perhaps municipalities or housing complexes that have also generated their own energy. So in many ways, it's a complex problem. It's a very difficult problem to solve. I think this is where the real machine learning and the real deep learning engineers and experts will work and create amazing solutions with small data. Eventually, even if you have today we're talking about a couple of 100,000 images, but in the end, even if you have 10 million images, it's nothing compared to Chat GPT, kind of, where people are training on maybe a data set worth a couple of 100 terabytes. But its value in terms of application in the industry is, I would say, significantly low when it comes to manufacturing and heavy industry. It's no value at all because that requires sort of new models and new methods of creating new energy sources. So my advice to all of you will be that do not get distracted by shiny objects out there. Obviously, you see us posting lots of fun stuff, but you should try to focus on energy industry. You should focus on aerospace. You should be focusing on solving hard problems in manufacturing. And this is where I believe we will be successful. So I hope it helps you. Thank you very much. All Hemanath, Soumya, all you guys, you were participating really well, answering all the questions. Thanks. And we will come back with another wonderful series where we will talk about more complex problems. And keep coming back to us, asking questions. We'll do our best to answer. Thanks, everybody.
Thank you.
Thank you, and take care. Ciao. Bye-bye.
Bye.